So very good morning. This is Dr. G. Ravindranath Reddy working as Assistant Professor in MLR Institute of Technology, Hyderabad. So in this video, we are going to find out how to find out the Fourier series for the discontinuous functions in the interval 0, 2L and L, minus L. So the Fourier series of f of x in the interval 0, 2L. So this is the arbitrary interval. In this, we will see how to find out the Fourier series of f of x for the discontinuous function here. So use the same formula which we have discussed how to find out the Fourier series of f of x which is a continuous function in the interval 0, 2L. So we are using the same formula a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L plus summation n is equal to 1 to infinity bn sin n pi x by L. This is the standard formula we will use. So whenever we have the interval 0, 2L, and these are the standard formulas we have to use to find out the values of a0, an and bn. And whenever we want to find out the Fourier series of f of x, which is a discontinuous function in the interval minus L, L, so these are the standard formulas we have to use. So same formula, but we have the different formulas to find out a0, an and bn, these coefficient values here. Now let us take one example in each interval which is a discontinuous function. Now we will see how to find out the Fourier series for the discontinuous function in both intervals 0, 2L and minus L, L. So now let us take one function in the interval 0, 2L. So now this is our function f of x. F of x is defined as f of x is equal to 1 whenever the x lies between 0 to 1, and the another value of f of x is 2 whenever x lies between 1 to 3. And for this function we are going to find out the Fourier series expansion in the interval 0, L. Now we have to, from these two conditions, we have to get the interval, and that interval we have to compare with 0, 2L. Okay, so now first we will see how to construct the interval of the form 0, 2L here. So we have two conditions. So 0 less than x less than 1, and the second condition is 1 less than x less than 3. So from these two conditions I want to construct the interval, and I will compare that interval with 0, 2L, and I will get the value of L here. So here whenever we have the conditions here like this, now from this I want to construct the interval. So take the first condition, and in the first condition you consider the initial value here. So that is initial value is 0. And now go to this last final condition and take the final value in that last condition here. So the final value of the second condition is 3. So our interval becomes 0, 3. And now you compare this interval with 0, 2L. So you will get 2L is equal to 3 and L is equal to 3 by 2. So like this, for the discontinuous function we have to construct the interval, we have to get the interval, and we have to compare that interval with this 0, 2L, and then find out the value of L. Okay, now take the standard formula to find out the Fourier series. This is the standard formula just now we have seen, and this similarly you compare this and get the value of L. So L is equal to 3 by 2. So now in this general formula, this is the general formula we will use to find out the Fourier series in the interval 0, 2L. Now we know the value of L here. So L is equal to 3 by 2. You substitute that L value in the general formula here. So you will get a0 by 2 plus summation n is equal to 1 to infinity an cos. If you replace L with 3 by 2, you will get cos n 3 n pi x by 2 plus summation n is equal to 1 to infinity bn. Here also you replace that L value here. So it becomes sin 3 n pi x by 2. So this is the standard formula to find out the Fourier series in the interval 0, 3. Okay. Now this is our required Fourier series expansion for our problem. Now we will find out the coefficients one by one. First we will find out the a0 value. So a0 value, this is the general formula to find out the a0 value in the interval 0, 2L. So here also we will replace that L is equal to 3 by 2. So you will get a naught is equal to 1 by L, that is L is 3 by 2. If you bring this L 3 by 2 to the numerator, it becomes 2 by 3, and integral 0 to 2L. So 2L, we got that 2L is equal to 3, so replace that 2L with 3. So f of x dx. Now in the previous videos we have seen only whenever the given function is continuous function, finally we replace that f of x as it is. But now here we are having the multiple values of f of x for this based on these conditions here. So whenever we are having more values for f of x based on the conditions, then here you have to divide this interval 0, 3 into subintervals based on these conditions here. The first subinterval we have to get from the first condition. Our condition is 0 less than x less than 1. So from this we can take 0, 1, one subinterval. And the next one is second condition. So you will get from the second condition, you will get 1, 3. So based on this, we have to divide this interval 0, 3 to subinterval 0, 1 and 1, 3. So 2 by 3, integral 0 to 1. That is the first subinterval we have considered. So f of x dx plus integral 1 to 3 f of x ds. This is the second subinterval here. Now for each interval we know the value of f of x. So whenever x lies between 0 to 1, we can replace that f of x with 1. So whenever the x lies between 1 to 3, we can replace that f of x with 2. The next step, we will replace this f of x values here. So after replacing this is our resultant integral. So integral 0 to 1, 1 into dx plus 1 to 3, 2 into dx. Now find out this integral values here. So and then substitute the upper limit and lower limit in both terms. So finally you will get our a naught value is equal to 10 by 3. So finally a naught is equal to 10 by 3. And then go for the next coefficient, that is an value. So an is equal to, defined by with this standard integral, that is 1 by L integral 0 to 2L f of x cos n pi x by L into dx. So in this case also you replace that L is equal to 3 by 2. So after replacing that L is equal to 3 by 2, you will get, this is our final standard formula to find out an value here. So now, this is 3. Now divide this interval into two subintervals. One is 0 to 1 f of x cos 2 n pi x by 3 dx plus 1 to 3 f of x into integral 1 to 3 f of x into cos 2 n pi x by 3 dx. So similarly here also replace f of x value based on these conditions here. So the first integral, the limits of this first integral are 0 to 1. So in this we can take that f of x is equal to 1, and in the second integral the limits are 1 to 3. So in this our f of x is defined as 2. Now replace the two values in both conditions. So now apply the integration. So integral of cos, we can take it as sine, this one, by, you will get the denominator. So I have taken the denominator outside here common from these two terms. So finally you will get sine 2 n pi x by 3 between the limit 0 to 1 plus 2 into, take this denominator after applying the integration, whatever the denominator you will get after the integration, you take this outside, and finally sine 2 n pi x by 3 between the limits 1 to 3. Now we are ready to substitute the upper limit and lower limit in both terms here. So after substituting the upper limit and lower limit, finally you will get this value is equal to sine n pi by 3 plus 2 3 by n pi sine 2 n pi minus sine 2 n pi by 3. So after substituting this upper limit and lower limit in both terms, so finally these are the final terms we got here. So now sine 3 by 2 n pi and sine 2 n pi, this sine 2 n pi in general we can take this value as minus 1 whole to the power of n plus 1 into sine n pi by 3, and here sine 2 n pi, that is 0, so we can neglect this value, becomes 0, and here the remaining one is minus sine 2 n pi by 3. So how can you get this sine 2 n pi by 3 is equal to minus 1 whole to the power of n plus 1 into sine n pi by 3. So you will get this value. So in general I have substituted the different values of n. So n is equal to 1, n is equal to 2, n is equal to 3. So whatever the values we got for this after substituting n is equal to 1, if you generalize that value is equal to this value here. So sine 2n pi by 3, I will write this one as minus 1 whole to the power of n plus 1 into sine n pi by 3. So here also you replace the same value here. So here you will get, so take this minus outside. So sine 2n pi by 3, we can take minus 1 whole to the power of n plus 1 into sine n pi by 3. Now after simplification here, you will get this value minus 1 whole to the power of n plus 2, 9 by this, 9 by 4 n pi sine n pi by 3. So this is our n value here. Now let us go for the bn here. Take the formula of bn. So this is our formula, and now replace that L is equal to 3 by 2 here. So after replacing L is equal to 3 by 2, you will get integral 0 to 3 f of x into sine 2n pi by 2n pi x by 3 into dx. Now here you split that integral limits as 0 comma 3 into subinterval 0 comma 1 and 1 to 3. So like this, and then based on these conditions here also you substitute the value of f of x in both integrals here. So f of x is equal to 1, and whenever that x lies between 1 and 3, that we can replace that f of x with 2. Now similarly here also you apply the integration, 1 and 2 are constant, so we don't have any problem with this after substituting f of x values here. Now integral of sine, we can take at it as minus cos 2n pi x by 3 by, you will get 2n pi by 3. I have taken the 2n pi by 3 outside here, and plus take 2 outside, and similarly here also you apply the integration of sine. So you will get minus cos 2n pi x by 3. So here you will get the denominator as 2n pi by 3. So I have taken this denominator here. Okay. Now simplify this by substituting the upper and lower limit in both terms here. So you will get this value here. So minus 3 2n pi into cos of 2n pi by 3 minus 1. So this cos of 2n pi minus cos of 2n pi by 3. So here also this cos 2n pi by 3 can be written as cos n pi into cos n pi by 3. So in both cases we have replace that cos of 2n pi by 3 as with this value. It's the same which we have followed in the previous slide to whenever we have discussed to find out the value of an. We follow the same procedure here. So this cos 2n pi by 3 can be written as cos n pi into cos n pi by 3. So now simplify this. So finally you will get that value is equal to, this is our final value of bn. So finally we will get bn is equal to 1 by n pi minus 1 whole to the power of n into cos n pi by 3 minus 1. Now we got a0, an and bn values. Now you substitute these values in the equation 1, which gives a required Fourier series for the given function in the interval 0 comma 2l. So now replace that a0 by 2 with this value. Finally you will get 5 by 3, and replace in the second term, replace that an value here. In the third term, replace that bn value. So now simplify this by taking the constant terms outside from the summation. So 9 by 4 is constant, so we can take that 9 by 4 summation minus 1 whole to the power of n plus 1. The remaining one is 1 by n pi sine n pi by 3 and this cos. And here also we can take this constant term outside. So after simplification, finally you will get, this is our Fourier series expansion for the given function in the interval 0 comma 2l. This is the way how we can find out the Fourier series for the discontinuous functions in the interval in the arbitrary intervals. Now let us take another example whenever we are having the interval of the form minus l comma l here. So we are going to discuss how to find out the Fourier series for the discontinuous function in limit minus l comma l. So minus l comma l, that is our interval here. So this is our problem, f of x. He has given that f of x is equal to 2 whenever that x lies between minus 2 to 0. and the another value of f of x is equal to x whenever that x lies between 0 to 2. Now for this function we are going to find out the Fourier series here. So now once if we observe the conditions of this f of x here, so here we are having -2. The first condition, the initial value is -2, and the second condition, the final value is 2. So here we will get the interval as -2, 2, which is of the form -L, L. So like this we have to construct the interval for the given function, and we have to compare the interval with our standard interval -L, L, and get the value of L. So we can take L is equal to 2 here. Now for this we are going to find out the Fourier series here. So as usual, this is our standard formula to find out the Fourier series, and these are the standard formulas to find out the A0 value, AN value and BN value here. So A0 is equal to 1 by L, and since our interval is -L, L, so we have to consider this -L, L to L as the limits of this integration, and AN value is also similar to this. The limits are -L to L, and Bn. So these are the standard formulas to find out the Fourier series in the interval -L, L. Now our interval is, in our problem the given interval is -2, 2. So now wherever we are having L, I want to replace that L with 2 in these standard formulas. Then we will get our formulas to find out the Fourier series in our interval -2, 2 here. So here L is equal to 2, and now one by one replace that values here. So after replacing that L value in the formulas, so these are the standard formula to find out the Fourier series. You consider this one as equation 1, and this we will use these integrals to find out the A0 value, AN value and BN values here. Now one by one we will find out that A0, AN and BN, and we will replace that values in the equation 1. Then we can get our required Fourier series in the interval -L, L here. So now A0 is equal to 1 by 2. So this is 1 by 2, 1 by 2. So 1 by 2 integral -2 to 2 f of x dx. Now replace, so here we are having multiple values for f of x. Based on that f of x, you have to divide this interval -2 to 2 into subintervals here. So our f of x value has defined as f of x is equal to, so this is our f of x value, f of x is equal to 2 when x lies between -2 to 0, and f of x value is defined as x whenever that x lies between 0 to 2. Based on this, you divide this interval, so -2 to 0 f of x dx, and the second condition is 0 to 2 integral 0 to 2 f of x dx. Now replace that f of x values here. So whenever that x lies between -2 to 0, we can substitute that f of x is equal to 2. Whenever that x lies between 0 to 2, we can replace that f of x as x. Now find out this integral values here and then substitute the limits. So finally you will get that A0 value is equal to 3 here. Now similarly take AN value. So AN is equal to, this is after replacing L is equal to 2. This is our standard formula to find out AN value. Now here also you substitute that, here split this interval G -2 to 2 into 2 subintervals based on the given problem. So first subinterval is -2 to 0 f of x cos n pi x by 2, plus the second condition is 0 to 2, so integral 0 to 2 f of x into cos n pi x by 2 into dx. Now as usual replace that f of x with its values based on these conditions, limits. So for the first limit -2 to 0, f of x has given as 2, so replace that. And in the second condition, whenever we are having the limit 0 to 2, we can replace that f of x with x. Now so in this first condition, in the first integral 2 is constant, so we can take that 2 outside, And here in the second integral we are having a product of two functions. One is x into cos. So here we have to apply integral of uv here. So take this and apply the integral of uv. We have the formula integral of uv is equal to, so integral of uv, this formula is very important in the Fourier series. So you will get u into v1, that is integral of v, minus u dash, that is derivative of u, into v2. v2 is integral of v1. So we have to follow the same procedure until we get the derivative of u as constant term. Okay, so we can expand this. Now follow the same procedure, same formula here. So here directly integral of cos, we can take it as this cos sine n pi x by 2 by this denominator, plus for the second integral I am applying this in uv formula. So u into, that is our u is x and v is, we have to consider as cos. So we know how to identify this u value and v value. So by taking the help of highlight. So x is an algebraic function, cos by default we can go for the trigonometric function. Out of these two, our algebraic function comes first here in this letter. So we have to consider that algebraic function as u and the remaining one as v. Now follow the same procedure, apply this formula. So you will get this integral value here. Now simplify, and finally after substituting this upper limit and lower limit here, so you will get this value. So this becomes 0, and here replace this. So after substituting the upper limit and lower limit, finally you will get, this is the final value here, 1 by 2 into 4 by n square pi square cos n pi minus 4 by n square pi square. So from this we can take this 4 by n square pi square outside common. So you will get, after taking that one, this 2 ones, 2 2's, so finally you will get 2 by n square pi square into cos n pi. We can take that cos n pi as minus 1 whole to the power of n. And after taking the total second term outside, the remaining one is 1. Now whenever we are having these type of terms within their brackets here, then we can go for the even value of n and odd values of n here. So if you take an even value, n is equal to 2, or if you want you can take n is equal to 4 and so on. If you take n is equal to 2 here, minus 1 whole square, it becomes plus 1, 1 minus 1 0. So 0 into anything equal to 0. So whenever we consider n value as a even value, we are getting that an is equal to 0. And similarly you take n is equal to odd values 1 comma 3 comma 5 and so on. You can take any value here. So you will get minus 1 whole cube, you will get minus 1, minus 1 minus 1, you will get minus 2, minus 2 into this constant term. So you will get minus 4 by n square pi square. This is the value whenever we consider n as an odd value here. Okay. Now we will go for the last coefficient, that is bn here. So use the formula, and here also follow the same procedure. So because we are having multiple values of f of x defined in the problem, so based on that we have to divide that interval minus 2 comma 2 into sub intervals here. Follow the same procedure, and then based on these limits here, integral limits, substitute the values of f of x in both integrals here. So here we have taken that value is equal to 2, and here the second integral limit we have considered that we have replaced that f of x is equal to x. Follow the same procedure what we have followed while you are finding that an value. Here also you follow the same procedure, take 2 outside, so you will get integral sine n pi x by 2. And then in the second integral we are having a product of two functions, one is algebraic and one is trigonometric. So here you follow the uv formula here, integral of uv. So after applying this integral of uv, this is our integral value you will get. And next step, you substitute the upper limit and lower limit here. So in this you substitute the upper limit and lower limit, and in this whatever the value we got after applying that integration by parts integral of uv, in that you substitute the upper limit and lower limit here. So here if you substitute x is equal to 0 in the first term, in this term if you substitute x is equal to 0 here, you will get cos 0, cos 0 is 1. So you will get, and now bring this denominator to the numerator, you will get 4 by n pi. And here if you substitute this x is equal to minus 2 here, you will get this value 4 by n pi, and similarly you substitute this upper limit and lower limit in both cases, so you will get this. So finally, after applying that calculation simplification, finally you will get that value is equal to minus 2 by n pi. So this is the value of Bn here. Now we got a0, an, bn values. Now you substitute that values in the equation 1 what we got in the previous slides. So now after substituting that a0, an and bn, this is our required Fourier series expansion for the given function in the interval minus 2 comma 2. Okay, this is the way how we can find out that Fourier series expansion for the discontinuous functions in the arbitrary interval 0 comma 2l and in the minus l comma l. Thank you.